One of the most important important things you'll be seeing in CICS, I mean in C-TREC, is its health check. Okay? And what the health check is designed to look at the entire system, but you can look at different portions of the system, and you'll see the screen on it. Okay, it'll basically analyze every single resource that you have in the system. I mean, it'll try to look at those 400 things that are out there and see if, or 400 plus things, and see if your system has any one of those, and it'll tell you that you have that particular one. Okay, and it'll identify those areas, and from those areas you'll be able to see which ones are using CPU and which ones that if you can fix, you'll be able to get a better CPU utilization. Okay, and again, it looks at your reliability. It looks at your response times. How can you improve your response times with the health check? Okay, and it's the entry point. When I'm going to go tune a system, that's the first thing I do. It gives me an overall picture as to what I have to look at in more detail. Which files are problematical, and why are they problematical? And and again, you'll see some of the displays here now. You look at it, okay? The list C-TREC provides the list of all 400 and something. In other words, you can go in that XX menu I was talking about, the miscellaneous menu. One of the entries in there, it tells you the list of all the different problems that or health checks that we look at, and you'll be able to see the base for it, and you will be able also to see why. If you put your cursor on one of them and hit PF1, it'll give you the reason that what that particular health check means and why it's there. So every health check is accompanied by a help display, and the help display is again two things: why are we identifying this situation, and two, how you can fix it, and three, if you want to add that, what you need to monitor to try and get, what are the things you need to look at to get the information. Okay. As I mentioned, if you look at the IBM health check on the CICS portion, IBM has done some major improvements in that area. In fact, the big move in version 6 CICS has to do with zero tolerance as far as security goes, and they have implemented quite a few things in the design. For example, in the kernel, you have something called the kernel table, domain table as such, and that domain table is by each one of the domains in the system. All 50 of them have an entry in that table, and that entry has something called gates. The gates are the functions that particular domain provides. For example, you can have a get main free main entry for the storage manager. Okay, and that the domain gate table is in there. Okay, and in the past that was not protected, so you as a user could have gone in and modified one of those addresses that instead of branching to the get main free main, let's say, portion of the system, it would branch to a routine that you would control, and then eventually go give control back to them. Well, that sort of thing now in version 6, you can't do that, okay? Because it's now protected by IBM, and vendors, some vendors that modify that. C-TREC does not modify anything within CICS, okay? But some vendors did. For example, Tmon modifies the kernel to where it has the trace table entries in the kernel anchor block. It modifies it so it goes into their routines. Well, that sort of thing now is taboo. It's no longer you have to ask permission, and you have to issue some special macros which IBM supplies, and you will only get them if you're a distributor. I mean, an ISV, and it sort of thing. Again, we don't do any modifications of any of the control blocks within CICS. Now you can modify them yourself using, if you're authorized, using the storage display function, but we don't recommend that. Okay. Some of the things that I've done, which modify when I'm testing, for example, I'll take the Keki transaction, which has a deadlock timeout of 10 seconds, and I want to make sure that that transaction stays active, doesn't get canceled after 10 seconds of being deadlocked. But I go in there and I modify that 10 seconds and put 4,000 seconds. So it stays there long enough for me to be able to analyze what I have to do in my program. Okay, but I did that manually. Okay, we didn't do that. C-Trek didn't do it automatically for me. And again, we are adding new functions as new things are added, and they come from various sources. One is when we do a performance type tuning, we find something that we didn't identify. We added it to us as our normal, new probs in there. And as I mentioned, we're working on 5 new probs right now that came from that. We also add probs because customers ask us for it. In fact, we add displays that because customers ask for it. Okay, remember that one I mentioned that we provide the task in username instead of transaction ID and transaction number. That was requested by one of our clients. They wanted to see who was using the system. So we added that function to it. So if you have anything in particular that you want to include or you want us to modify, we can find the control block and the information. You can be sure we'll provide it for you. And when we provide it for you, we'll also provide it for all the customers that have C-Trek installed. And some of them, again, we've had to include because of new CICS features, okay, things that they did. There's a change right now, for example, in C-Trek 6.1 dealing with T-class. So we added that particular problem to it. And then there's a new area which IBM has been implementing in version 6, which is the security portion. So we're adding some zero tolerance security type information. Things like, for example, you have DB2, but in the SIT, you didn't put DB2 as the XDB2 parameter to have some type of checking for people who are accessing DB2. So these are some of the things that we are adding as IBM modifies and includes new things. Okay. Any questions? Okay. Here's when I select the health, and this is the SU option that I mentioned, which is the performance options part. You'll see one which is over here on the left-hand side. You see health, HLTH. When you issue health, and you can issue health 2 ways. You can enter HLTH up here, or you can put your cursor anywhere on the line. Okay, we're not like some monitors that you have to put the cursor on the first position. Anywhere on the line, you just put the cursor and hit the enter, and you'll get this sub-menu. And it says, do you want to see all the problems? Are you interested just in the CICS ones, the DB2 ones, the file ones? So depending on what you're interested in looking at, we normally, the default is A, so you're going to get them all. But you may just be interested in just solving the CICS ones. You would enter C here, and you just look at those out of those 400, those that have to do with CICS itself. Okay. And again, these are the different functions that we have. And then you can do, I just want the informational one. You'll see when we see this in a second. You'll see the warning and the potentially severe problems, and I just want to see the system information message. Okay, so these are the options that you have. Normally just hit enter and take a look at all of them. However, if you have a very large system and it has a lot of problems, you could wind up, pages and pages and pages of problems. And it gets a little bit hard to do the debugging, so you may want to break it down a little bit. Okay. And now this is what you'll get. And the first part is just what we call the system information messages, and it gives you the information as to how the CPU is running, as from a general point of view, and how is your CICS running in this particular case, and how much of that 2.04 is your CICS 6.1. Then it tells you, how am I doing in my memory? Am I using any memory? And this right here, the GDSA, I'm not using any, okay? But this, I'm using 33% of what's allocated in the DSA limit, okay? And it gives you the information as to how many frames your CICS is using. It's using 109,271 frames. That's multiply that by 4, and give you the amount of real storage that you're being used. by 4096. Okay, and if you and that real how many are being used in your slots in your page data sets. So you'll have both information for your systems. Okay, your system is processing how many transactions per second at this point, and in your PLPA comment again, do you have enough space for it? And again, you're only using 9%, so you're doing very well. Then it starts looking at the different things. In this particular case, it starts with the VSAM files. It tells you, I have a file called share43 that's using share options 4, which is not recommended. Recommended is to use RLS, okay? Then it says, oh, you have this file called share13, share14, and so on. And these files are not only using share options 4, but they're in LSR pool 1. If they're in an LSR pool, they're being used. That's a very bad use of buffers. Because LSR uses something called the least recently used. In other words, in the buffer that's made available, when you run out of buffers, which is the next one? If somebody needs a buffer, which is the next one's going to be given to them? Is the one that's the oldest that has not been referenced. Okay. The problem is with LSR 4, I mean share options 4 files, every direct read has to, for all effects and purposes, has to be read. So even though you have the record in the pool, if you issue a read for the same record or the same CI again, it's going to basically leave the old one in there and give you a new buffer. As you can see, you start basically eliminating good buffers for buffers that you'll never reuse again. So that's why it's in red. It's a very poor decision and so on. Then it goes in, and again, this is just the first 2 pages and so on. We can see a lot of other things that you're interested in more later on. It'll go in and analyze for you. Okay, this particular file called CTREC BKH, 60% of the control areas are splits. That represents whenever you have control area splits, you get 50% of a cylinder. Your file is defined as a full cylinder. 50% of it is empty. So you're wasting a lot of space with CA splits. So it's telling you, take a look at these files and make sure, number one, and we'll see a help, but we'll see it for the control interval splits. Okay, and again, it's in yellow because it's not, something. You'll see up here at the top, it'll tell you have a total of 226 messages, of which the first 9 are informational, which are the blue ones we saw. Then the yellow ones, we have 28 warnings. We have 33 potentially severe, which are these red ones, and informational, which are the white ones. Okay, for example, this one says, here you have a file called index1, which has free space specified, but you have no insert activity. Okay, well, why do you have free space there? Is it really necessary? And if it's not necessary, eliminate it, and that way you can recover this space, and you can recover for whatever it may be. Now, if this is a small file, it may not be important, but it's a file that has thousands of cylinders. That could be an important amount of space that you can recover. Okay, so anytime it'll go through there, and in this particular first case, it's going to go through the VSAM files first, and it'll go through the SID, it'll go through temporary storage, it'll go through transient data, it'll go through all the different things that you have in the system. It'll go through DB2, it'll go through MQ, it'll go through Java, it'll go through, and again, at the end, it'll go through LSR. That's some additional information about LSR. Okay, so it takes about 10 seconds. Most of the ones I've seen today, the last weeks or so that I've used, is around 9.3, 9.4 seconds. Elapsed time, CPU time about 275 to 300 milliseconds. Okay, so it's a very inexpensive type operation, but it's very valuable because it identifies all the things that you need to look at to improve the performance of the system. Any questions on that? Okay. And if you want to see why a particular entry is there, you put the cursor and hit PF1, and it talks about that in this particular data set that I was looking at, okay, it has too many CI splits. It says CI splits require additional IO operations. Now, one of the things which you're going to find whenever you read books, performance books, you're going to see that everybody sort of downplays the CI splits. You know, they're concerned about CA splits, but CI splits are important, okay? Because look at number 4. CI splits result in CI having approximately 50% free space within the CI. This file is in LSR. In CICS, the resulting buffer would only be approximately half full. So now you have a buffer. Before, for example, you had a CI that had 10 records. Okay, one buffer you had access to 10 records. You get a CI split, you're going to wind up with one with 5 records and one with 6 records. But you need now 2 buffers and you need 2 IOs to get to it. Okay, so there's a hidden what do you call it? A hidden agenda, I guess, to tolerating too many splits. Now, you look at a file that has 50 CI splits, well, big deal. I mean, it's not really something big. First of all, not all 50 necessarily are in the LSR pool at that point. But you get a file that has 40,000 CI splits, you know, and it's in LSR, you're pretty sure that you're going to have a lot of LSR buffers that are going to be half full and are taking a space up. And that means, you know, you should look at, you know, tuning that file, either the free space or reorganizing it a little bit more often, okay, to reduce that, okay. Any questions on that? So each one of these help messages has, each one of these health check messages has its own help, and it identifies what it is and what can be done to try and fix it.